I'm really looking forward to the chance to answer questions that you all have. So, entitled today's talk, Multimodal Interfaces for Equity, Exploring Opportunities for More Equitable and Inclusive Learning Through Multimodal Technologies. The game plan for today, and just in case anybody happens to fall asleep a little bit later on, wanted to go and show you what the 4 takeaways are. And the first one is really around intentionality and the ways that we incorporate ethics and equity into the entire research cycle. So I'm going to touch on that a little bit today. The second one is that multiple interfaces can make learning environments more accessible, and they can also promote complex problem solving. So that's one thing I'm going to emphasize. Multiple analytics can provide innovative techniques and technologies that allow you or users to learn about learning. And then fourth, multiple technologies offer a generative space for people to learn by designing innovative technologies and experiences. So those are the 4 big kind of ideas that I'm going to be touching on during today's talk. And I'm going to try to give you some examples of each one of these. And all of these things too are based on some recent papers that I've written. And so I will mention those on each of the slides, so you can have a chance if you want to go take a look at those papers in more detail. General agenda, I'm going to first quickly introduce my lab, Tilt, and then we're going to get into talking about some core commitments, and then talking about multiple interfaces, multiple analytics, and multimodal learning. So, this work is done in conjunction with my lab. My lab is called Tilt, Technological Innovations for Inclusive Learning and Teaching. You can find us at tilt.northwestern.edu. I've got a fun group of PhD students. Those are the ones that you're seeing pictured on the left-hand side of the T, and then a group of undergraduate students, and I will say not all of them are even pictured on here, but an exciting group of undergraduate students who have really been helping to drive this work forward. So the mission of Tilt is fundamentally to tilt the balance in favor of those who have been and continue to be marginalized. And with that, equity is the central goal. And a part of advancing equity, in my view, is also centering those marginalized identities. I won't necessarily talk about them at length now or in this talk, but for example, I teach a couple of classes at Northwestern. And in addition to teaching sort of intro to HCI, I also teach a class called Inclusive Making, which is really about trying to center disability within computer science, and make sure that we don't treat it as something that we try to ignore, or don't treat it as something that is sort of an afterthought. Inclusive making is really about trying to center disability as a really positive contribution to our space and really put disability in conversation with computer science. I have another class that I teach called Sports, Technology, and Learning, which is really about centering an athletic identity within a computer science context. And both of these, disability and athletics, tend to be things that I think sometimes people feel like they have to leave outside of an academic context. And I'll say more broadly, I feel like many people have relayed to me that they oftentimes feel like within some computer science, AI kind of spaces, their identity is not necessarily welcomed, or their identity is not really seen as an asset. And so a lot of the work that I'm trying to do is really center those identities and make sure that we're setting up spaces where people feel comfortable talking about those identities. And again, as we recognize those identities as bringing important value to the space. Now, on top of this idea of centering equity and centering identities, I really focus on work in 3 areas. They're pictured here: multimodal interfaces, multimodal learning, and multimodal analytics. And I fundamentally see these 3 areas as being interconnected. And so that's probably the other big idea I'm going to try to leave with you today, is that all of these areas, multimodal interfaces, multiple learning, and multiple analytics, can really be used in service of one another in order to help advance some of the goals that we want to see on both the theoretical side, as well as some of the goals that we want to see on the sort of the practical and applied side. So what I'm really going to walk through today then is going to be talking about some initial core ethical commitments, and then talking about projects within each one of these areas: multiple interfaces, multimodal learning, and multimodal analytics. So to start off with core commitments, one of the things that started to happen with the introduction of more artificial intelligence, the introduction of more multimodal technologies, is increased concern about how these things might be used to honestly to abuse or to marginalize certain populations, certain groups. And so one thing that I've recently written on is this idea of what are a set of core commitments that we should have as we go about trying to design with these different types of multimodal technologies, in particular ones that sort of incorporate elements of artificial intelligence. Now, I'm not going to go through all of the 12 that are listed here, but part of what I'm going to suggest is that we want to think about the use of ethical, equitable, and inclusive practices across the entire research pipeline. You know, when we start up a research project, we have to decide who it is we're going to collect data from, what kind of data we're going to collect, how we're going to collect that data, and then subsequently move into how do we analyze that data, and then finally, how do we disseminate that data. And what I suggest is that within each one of these phases, data collection, analysis, and dissemination, there's some important things that we have to think about that have important implications for equity, inclusion, as well as ethics. And again, I'm going to touch on one of them from each one of these buckets, and sort of encourage you, if you want to look more at those, to check out the paper, or you can ask me about them later on. So the three that I'm going to touch on is multimodal data control, limitations and predictions for multimodal data, and lastly, meaningful usable feedback. So under data collection, the first thing I'm going to touch on is really this idea that participants should have control over when data is collected about them. I think we live in a world, and I want to say last year, during the pandemic, there's a number of articles that came out about, you know, concerns about when Amazon, for example, is collecting audio data from their smart speakers, for example. And I think there's an important commitment that needs to be made around allowing people to control when these different types of multimodal data are or are not being collected about them. That introduces some methodological challenges from a research perspective. But in my view, that is something that we should be designing for. And I think it'll be important for trying to ensure that we have a more equitable future. The second one is one that I'm fairly passionate about. And that's this idea that within data analysis and inference, we really need to acknowledge the limitations in the predictions that we get from multimodal data. And concretely, what I mean from that is that we have to really avoid this practice of defining our research participants by their behavior in a given study. So in the education research space, this sometimes happens where you have students complete a standardized test, and those who scored high get labeled as high achievers, and those who scored low get labeled as low achievers. In other instances, you might have labels for kids where you call them engaged students or disengaged students. Part of what I'm suggesting with this, and I think this becomes increasingly important with the use of AI and different kinds of multimodal systems, is that we move away from that practice and recognize that the behaviors that we saw from a given participant are highly contextualized, and to acknowledge the fact that many times these predictions themselves, as they emerge from AI and sort of machine learning based systems, are biased. And so that when we go to the step of assigning really what ends up sometimes being used as a sort of like final label about somebody, we really are, in my view, doing a disservice to them and doing a poor job of representing the contextualized nature of the data that we've collected, as well as the contextualized nature of the analysis. So that's sort of the second idea, is that behavior does not equal identity, and we really need to be cautious about how we talk about participants. And then lastly, as it relates to feedback and dissemination, you know, one of the commitments is really to providing meaningful, usable feedback to participants. And this is not to say that we're not interested in growing theory. It's to say that I think there's important ways that we can grow theory alongside actually providing usable and useful information to the participants in the studies that we end up having. So then, big picture, I mean, this is that sort of first takeaway, is to kind of be really intentional about the ways that we're thinking about equity, inclusion, privacy, ethics throughout the various elements of a research project. It's not sufficient to use an equitable practice in our data collection, but then subsequently, when we do our data analyses and disseminate our work, to kind of throw those things out the window. So that's the sort of first takeaway. All right, now with that sort of groundwork laid, we'll actually get into talking about some of these different kind of multimodal interfaces. So the first one we're going to talk about is related to a platform that my lab has been developing called Multicraft. And I'm going to suggest that Multicraft kind of demonstrates the ways that AI can power different sorts of innovations that make learning environments more accessible and that promote complex problem solving. Quickly, by a fast reaction, how many of you guys recognize this picture? Can you get like a thumbs up or some sort of Zoom reaction if you guys recognize this picture? I'm seeing a handful. I see a thumbs up. Any others? Anybody else recognize? Yes, a few. Okay. So this picture is from a popular virtual reality game called Minecraft. And the Multicraft project really came about because I was visiting a middle school classroom where at the end of the unit, when students have finished their projects, and these projects can be involving things like Photoshop or using Adobe Illustrator or 3D printing. When students finish up their projects, the teacher allows for them to spend some time designing and building in Minecraft. In this specific class, though, there was a young black eighth grade boy who had cerebral palsy, which really inhibited him from being able to simultaneously use a keyboard and mouse. And for those of you guys who know about Minecraft, one of the ways that people canonically use the game is to put one hand on the mouse to be able to control where you're looking, as well as to control mining and building. So either breaking blocks or like putting blocks down or opening doors, and your other hand on the keyboard and using the WASD buttons to actually be able to navigate around this virtual world. So for this specific student, because he had cerebral palsy, he was not able to control the keyboard and mouse at the same time. And that effectively kept him from being able to play the game, effectively kept him from being able to participate along with his peers in this experience. And for me, that was very frustrating to see. And that's really one of the things that motivated us trying to develop this Multicraft platform, where Multicraft is this, ultimately it's a plugin, a Minecraft, it's a Minecraft server that we host that allows for people to interact with the game using speech-based input, using eye tracking. They can still use a keyboard and mouse if they want to, though we have introduced some shorthand text input so that they don't have to type out full commands. They can interact with the game using wooden blocks, using EEG. And we've recently been working on adding some computer vision-based gesture recognition. So the idea is really that we want to provide as many different modalities as possible for participants to be able to participate within this Minecraft experience. And as part of that, it's not just that we want to replace the keyboard and mouse. We really are trying to get towards equitable participation. So for us, it wasn't sufficient to just replace the mouse, for example, with an eye tracker, or to have a virtual keyboard show up on the screen and the student to use eye gaze to control it. We really wanted to make sure that the play was going to be equitable. So we also embedded a number of sort of commands that can even speed up the play. I'm going to show you in the next few slides a handful of examples of how we're using this multimodal data, but just wanted to give you a quick picture of the architecture. A few of the things that we've been adding in recently is that we previously had a lot of the Multicraft client actually reside within like a Python program. We recently switched that over so that it's primarily browser based. And so we're trying to think of as many ways as possible to make these things accessible. We've also switched out our previous use of the Tobii 4C eye tracker and can now do eye tracking using just a webcam. So the goal is really to try to provide an experience where, once again, students are able to use whichever of these technologies they have access to, and to really allow them to find new ways to play the game. So here's just an example of a video from where somebody provided verbal instructions to the game and the sort of structure was built instantaneously. So this is an example of how we're thinking more about equitable play. And so instead of just having a verbal instruction that says, put a block down, put a block down, put a block down, move over, put a block down, we actually allow for the students to make a verbal command that will actually create this entire structure at all at once. The next slide here is showing an example of a sort of eye tracking overlay. When the students are actually playing the game, they don't see that little bubble in the middle of the screen. That's something we can easily turn on and off. But in this case, the student is able to use their eyes to be able to look around and actually control where their avatar is looking. And within some of our commands too, we do allow multimodal fusion, which means if I'm looking at a certain location and I say, make a 5x7x8 structure here, it will actually build that structure where I'm looking. So we are really trying to think about bringing together these different kinds of multimodal commands. The other pieces that we've incorporated, one of the ones that I'm really excited about is the ability to build using wooden blocks, or really build in the physical world. So on the right-hand side, you're seeing one of the prototypes of a platform called Tangicraft, which was at that time it was a set of laser cut blocks that we created with fiducial markers on them, as well as we had created a sort of haptic feedback device that was really geared towards allowing someone who was blind or visually impaired to be able to play Minecraft. On the left-hand side, you're seeing a somewhat updated version where instead of having to have blocks that have specific fiducial markers on them, we can just use any sort of generic blocks and use that as a way for people to design and build with. And on the next slide, I'm actually going to have a quick video of a slightly more recent version of this. On the right, you're going to see someone adding in blocks. And then on the left-hand side, you'll see those blocks showing up in the game in real time. So they're going to add two more, and those two other blocks are going to show up in front of it. And so this is kind of an example of the user experience we want to be able to have, and actually what we currently do have, where as a participant is adding and removing blocks, and again, these blocks in the physical world, the game is nearly in real time making updates to actually reflect that. And this, as we've explored it, has important implications and provides new ways of engaging that enhance accessibility. But there's also some important ways that this provides for different types of engagement. So I don't know how many of you guys have ever watched a group of middle school students try to play Minecraft together, where they're all using the same computer. But I can tell you right now, it typically doesn't work. That many times the students are sort of fighting over that keyboard and mouse to kind of be in control. If instead we allow for participants to use physical blocks, it makes it much easier for them to be able to engage in collaborative building, even though they might all be connected to just one single user within Minecraft. And that's some of the things that we're really trying to advocate for, is to not just, again, replace the keyboard and mouse, replace the input modality, but also try to promote different ways of engaging, and even try to set up a scenario, for example, where perhaps it's a young kid who does not feel comfortable using any of the other input modalities, whether it be keyboard and mouse or using speech, that they can actually build with these physical wooden blocks. Or it can actually be an adult and a child coming together to collaboratively play in this experience together. So one of the neat things with this too, though, is that alongside using the multimodal input, the multimodal data for people to control the interface, there's also ways that they can actually we can use the multimodal data to study what they're doing. And this has been providing us an important window into thinking about spatial reasoning in particular. And so these green dots you're seeing on the screen are sort of an eye tracking overlay of the information that the participants were sort of visually engaging with, that is helping us see the ways that students are practicing traditional spatial reasoning practices within Minecraft, as well as helping us see some kind of honestly new kinds of spatial reasoning practices that we would not necessarily see within the physical world. So this, this will start to bring me to the next point. And I'll quickly say Multicraft as a platform is really motivated by goals of accessibility. But we've also really been using it as a way to engage students in computational thinking and spatial reasoning and help us see that computational and spatial reasoning. So big picture, multiple input opens up new possibilities for inclusive and equitable learning, while also facilitating practice of complex skills like spatial reasoning, like computational thinking. But at the same time, these multimodal interfaces can be a really cool way to go about trying to study and support learning. And so to give you an example of this, we're going to now turn to multimodal analytics, where I kind of suggest that AI can provide innovative technologies and techniques that allow you or users to learn about their learning. So this is part of a paper, connected paper called Designing Analytics for Collaboration Literacy and Student Empowerment that came out earlier this year. So the sort of guiding question around this project was, what does good collaboration look like? And, admittedly, researchers have been studying collaboration for a long time, right? And researchers have even come up with these sort of complicated maps of, okay, here seemed to be a number of different themes that people look at related to collaboration. And now we can break those themes down into these different categories. And then those categories can be subsequently sort of grouped into different domains. And all this information is actually, it's really, really informative for helping researchers in particular think about collaboration. But one of my big interests is, what does this mean for students? How is it that students think about collaboration, and how do we go about representing collaboration and collaboration information to students, specifically with this goal of helping them develop collaboration literacy, which is, I sort of describe as their ability to know how to collaborate, but also to know how to read a given collaborative situation and to know how to respond. And so that's sort of the guiding question for this current project that I'm going to talk to right now is called Blink. How do students think about collaboration? So to do this, we're going to, and so as part of this study, we ran a survey a couple years ago where we got input from undergraduate and graduate students about how they collaborate, what good collaboration looks like, what bad collaboration looks like, what kind of things they would tell someone else about collaboration. And that gave us this sort of category, this set of categories. And I won't go into the detail about all these categories, but what they started to help us do was to inform the ways that students seem to be thinking about collaboration. And that's important because what we're working on and what we've been developing is an interface and really a data analytics dashboard that is there to try to support student real-time as well as post-hoc collaborative sessions. So we're going to try this. If you guys can go to tilt-blink.com, it shows up on my screen here, tilt-blink.com. I'm going to sign in, and we'll see if this is going to work. So what I'm doing is I'm creating a discussion, I'm setting up to create a discussion. When I do this, I can create a custom keyword list. These will be words that the tool will pay attention to. I'll press next, and I'm going to start my discussion. Now, if you all, like I said, if you went to tilt-blink.com, you'll have this option to join discussion. So if you click on join discussion, and then type in your name. It doesn't really have to be a real name. You can choose a fake name. So I'll even put in none. And then we're going to put this code QM43 in here. QM43. I'm going to say join discussion. So now what we've done is I have connected, you guys are basically all connecting to this platform, and you guys are now participants in this sort of full class discussion. The idea behind the Blink platform is multifold. One is this idea that what happens in a classroom, typically happens in a classroom that has a large number of users in it, is that we typically engage in lecturing. And part of the reason why we engage in lecturing is because it's hard to manage a classroom that's having a lot of small group discussion. And so one of the things we thought was, okay, well, what happens if we actually set up these audio data collection devices inside the classroom space so that if an instructor wants to click in and see what's happening within a given group, and actually my guess is there's not going to be much audio because I'm doing most of the talking right now. But if an instructor wants to come in and see what's happening within a given group, they can click into this display and they'll see what kind of verbal information is being captured. So it should work if I go into none. Let's see if it's gotten any audio. So when I clicked into none, this was the one that I was using. You'll see there's a transcript of the words that I was saying. And so this is one of the things the platform provides. It'll do real-time speech recognition and then provide that information for the user to be able to look at. Within this too, it does something. Oh, I didn't want to go back here yet. It will provide me with a sort of timeline of when it detects text, when it detects a discussion. It'll identify when it detects a question. So like, what's the day today? And also annotate silence. Down here, we have and this is a representation we're still working on with this specific, with this kind of microphone. But we also have it set up with a specialized microphone array that will give you a sort of a heat map, or more so a visualization of how much verbal contribution is coming from different portions of a small group. Down below, you're seeing like a keyword detection. So maybe this is a chemistry class and you want to keep track of discussions related to, I don't know, covalent bonds or ions or protons, or I don't know, phenylalanine or something. You can customize a set of keywords that you want to be able to sort of quickly go in and identify. And then you also have these discussion features. So this is using sort of a sentiment classifier to look at the emotional tone, analytic thinking, or clout of different utterances. So when we go in here, I think I asked a question. Something didn't want to go back here yet. I'm not even sure that I said that, but oh well. Some of the other representations that you get with this tool, one, you can click into a given keyword and it'll take you to the transcript. You can actually see a full transcript of what was said. The idea here is that this is something that is hopefully useful to a group who's engaging in a group discussion in that moment to kind of say, okay, what were we talking about previously in this discussion? And you can sort of highlight where those keywords came about. The other neat view with this is looking at the graph. So if I go into this graph, I can actually see all of the group discussions at the same time. Now, with as many people that have signed in as there have been, it's going to be a lot. But what you'll see is that I can sort of quickly look at a given person. I can click on a certain device and see, here were the questions that arose from their microphone. And then here, just more generally, sort of an overview of the relative contributions from each of the groups. So this is just this is an example of a live platform that we've been working on that is really aimed towards trying to represent many of those concepts that I was just showing you guys. Many of these ideas, being able to represent climate, communication, compatibility, conflict, context, contribution, and the sort of constructive category as embedded within a sort of collaboration analytics tool that we see as trying to provide real-time support for students, as well as supporting research. And again, the goal being that these kind of tools can support more inclusive and more active kind of classroom experiences. So I won't get into sort of details with all this. I will quickly say though, the idea of being able to do this from your smartphone was something that came up as part of the research, because one thing that we observed, especially in higher education, a lot of the collaboration that happens outside of the classroom space. So we wanted to make sure that we had a tool that students could essentially use on their time outside of the classroom that is going to record this information for them, and then subsequently be there for their teams to be able to use in the moment, or for them to go back and look at later on. But big picture, I kind of see this idea of AI and multimodal analytics can really help us think about how we learn to collaborate, and ultimately want to suggest that for certain constructs and even certain practices like collaboration, we really might want to have more of these computational tools that are using multimodal data, as I think those can help support and characterize how collaboration is being developed. So in the case of learning collaboration, you know, instructors have very little window into what a collaboration looked like in your dorm room, in your residence. But if you're able to have a sort of data collection tool like this that has some various analytic components in it, that could potentially inform or improve and even offer some support for students as they're trying to collaborate. And more importantly, it can also go alongside some pedagogical approaches that an instructor might take in trying to help people reflect on how they were collaborating. All right. The last piece is, you know, we were just looking at collaboration as a context. We looked at sort of multimodal, we looked at Minecraft as a context. I also get really excited about the ways that we can use multimodal technology as a way to engage people in learning through designing those multimodal technologies. So this work is related to a project that calls SportSense. It was previously called Data in Motion. You can check out some of the stuff on this at tilt.northwestern.edu/projects/sports analytics. And the big picture behind SportSense is really trying to again to center identities related to athletics in an academic context, and to say that there's important ways that athletics can be used as a space to learn about artificial intelligence, and there's important ways that artificial intelligence and multimodal technologies can be used to improve athletic performance. At the professional level, I think people see a lot more of this, but as sort of at the youth level, I think it ends up being a lot more opaque. And people really start to think about these two areas as separate silos and not seeing the opportunities that exist, that can exist between them. So this work is actually, it's work that do in collaboration and in partnership with several different organizations. So Evanston-Skokie School District, where we work with physical education and coding or computer science teachers to incorporate some activities and design some activities that have relevance and connection between PE class and coding class. We're working with the Chicago Parks District and working with many of their after-school educators to embed some of these experiences as part of the after-school space. Work with the Evanston Public Library. We're working with a basketball team in Puerto Rico, so Vocacional de Ponce. And then we're also working with a number of other organizations within Chicagoland. One of these, the Block, is a youth boxing club, and then we've been working with the Evanston Township High School. But this is just to say that we're seeing a lot of spaces where we can actually engage in this kind of work, both informal and formal. Big picture, and there's actually a lot of stuff I can talk about with SportSense. What we've ended up developing so far is a curriculum that we came up with primarily for the pandemic, that goes through 6 different weeks, or sort of like 6 different modules. The first one is this idea of the power of sensors. And we ended up developing this module because kids seem to have a hard time thinking about sensors, and they had some concerns about, you know, what is a sensor? And so we sort of expose them to the idea of sensors through Spider-Man Into the Spider-Verse, and start to help them think about the types of digital sensors that many of us use or that are embedded inside many technologies that we have, many of those things are actually modeled after human senses. And so we really try to ground the idea of sensors in our human senses. We then move on to have the students start to explore some low-cost wearables. So the microbit is one of those wearables that we have them use. And one of the neat things you have to do with the microbit is actually replicate some existing, at sometimes expensive wearable technology using the sensors on the microbit. And this ends up being like a powerful experience for them, because many of them kind of look at this and like, wow, I had no idea I was actually able to create something like this. And the really neat thing is that these microbits, there's a the programming language for them is block-based. And so it's something that many of the youth feel comfortable doing. Next step is we have a module called Take Off That Silly Watch, where we kind of say, all right, let's put the wearables aside and let's see what we can do with computer vision. And so we actually have them replicate, again, another commercial application that's part of this home court basketball app. We have them replicate that in the Scratch programming environment using some of the built-in computer vision capabilities. And once again, it's another one of those things that students do, and they kind of look back in disbelief of that they were actually able to create something like that. We then have a couple of sessions where we talk about limitations of sensors and wearables. So we actually encourage them to try to hack some of the technologies that we've been using. And really, when I say hack, I really just try to trick them. So how do you trick a step counter? How do you trick a computer vision system that might be counting how many push-ups you're doing? And then we also talk about some of the more societal level challenges, societal level problems that arise when using facial recognition technology, for example, and the ways that sometimes those technologies are used and they violate people's privacy. And other times we also see them used to criminalize people, in particular people of color. We also take them through a design thinking process. And we have them complete a number of different design activities. One of the sort of design activities we have them do is create a sort of a design comic. So, think about a specific technology that they might want to make and kind of put together a little comic around it. And then we also highlight many designers of color. So on the right-hand side, you're seeing Stephanie Lampkin. Stephanie was a Stanford alum in, I want to say electrical engineering, mechanical engineering, or CS. I sadly don't remember. But Stephanie was a contemporary of mine, and now is now CEO of a company there in the Bay Area. And so what we do in this space, we have various types of programs. So one of them is we'll do these pop-up sessions where we'll actually have students go through this process of like drawing out their different design ideas. And so here are just some pictures of some designs that students have created. On the left-hand side, you're seeing a dancing robot that's supposed to teach someone how to dance. In the middle, you're seeing a golf ball with sensors inside of it that lets you know how hard you hit it. And then on the right-hand side, you're seeing the sort of robot coach. The neat thing is to see the ways that students have some pretty powerful ideas. And once they get access to the tools to start to create and build out those ideas, they become extremely empowered. They begin to see more of their agency. And so really the big idea here then, I'll get to mention that. The big idea is that really engaging people in embodied experiences where they design AI-powered multimodal innovations can be a general approach for learning. I almost forgot to mention, one of the things that we've started to see with these programs is that we can, even in the course of a quick week, I see students drastically shift in their perceptions of the connection between technology and sports. So within this group of students, I think it's from a summer program, when the students started the program, most of them did not see much of a connection between technology and improving in sports. And after just a short 5 days, the students started to actually see that as an actual opportunity and see connections between technology and improving in sports. And this work is part of what motivated us to start working with teachers, in particular PE teachers and coding teachers at the elementary school level. And so we've been co-developing some activities that are built around those 6 modules that I shared earlier. Okay, so to kind of wrap things up, hopefully I've touched on each of these four takeaways. Really, this idea of being intentional across the entire research lifecycle, the idea of multimodal interfaces being a way to create learning environments that are more accessible and that at the same time can promote different types of complex reasoning, complex practices. The multimodal analytics can provide innovative techniques and technologies for studying learning. And then that lastly, that engaging people in the design of multimodal technologies that are oftentimes leveraging AI can be another important way to promote learning. And now to get back to this thing around equity and identities, one of the things that I've really been interested in is how do we go about designing new kinds of learning experiences? And that's part of the way I kind of come into this work, is how do we come up with these new ways of creating these learning experiences? But that also has to be coupled with ways for how to assess and support. And so hopefully from there, you kind of see some of the connections between these three areas, between multimodal learning, developing multiple interfaces so that those multimodal learning experiences are accessible and that they are engaging and that they're allowing people to do things that might otherwise seem infeasible for them. And then alongside that, see the ways that the multimodal analytics can build off of those multimodal interfaces to support the multimodal learning experiences, as well as to really sort of drive the multimodal interfaces. So with that, I will conclude, and it looks like we should hopefully have about 15 minutes or so for questions. Thank you.
Evaluating collaborative teams, like for example, I don't know if you've used the CATME tool before or other ones like it, but basically that rely on basically student teams self-reporting, basically their collaborative different measures across collaboration versus, which I think have been shown to be biased, right? That will basically, people that have been traditionally, minoritized tend to be, fare worse on self-reported measures, and the perception of team members is skewed by these biases that people have. So there's obviously problems with self-report. At the same time, there's sort of issues that you kind of brought up in maybe the first part of your work that you mentioned, in terms of sort of the aspects of surveillance and what are the sort of ethics and how people are, aware of or concerned with, basically having these collaborative meetings recorded and then knowing that that's going to affect their grade. And
technologies. And when I think about the analytics, as I really think about them as a complement and part of like a full mix. I was in a talk yesterday where there was discussion around the fact that it's not that we want to avoid conflict or not avoid conflict. It's not that when you get differing signals from different modalities, whether that is coming from self-reports, whether coming from audio data or video data, it's not that we're trying to necessarily fight to see which one of those is the best. It's that we're trying to do what we can to, sorry about the sneeze. Oh wait, no, maybe not. Do what we can to try to get a holistic picture and kind of a conversation. Thing I'm going to say about the Blink platform is that none of what we try to do is to be prescriptive. So at no point do we try to say you're not talking enough. At no point, there's no point where we try to say you need to listen more. And a lot of that too has to do with the specific context, and that typically we only have a very limited window into that context. And this is also something that students raise concerns about when they're thinking about analytic tech, collaboration analytics, is that there's oftentimes so much context that the concern is that the predictions that they get, the prescriptions that they get, are not going to do a good job of reflecting that context. And so that's one of the ways that we tried to approach this for now, is we're going to surface information, and we really want that information to be connected to some structure that is actually designed to help people learn about collaboration. And this is probably a whole nother rant that I could go on, but I'll spare you. But generally, I don't feel like we actually teach people to collaborate. We just kind of say, okay, go and work together. we don't provide much scaffolding around the collaborative experience such that people are actually learning to collaborate. And so one of the goals of this kind of tool is for it to be connected to a more structured or a more formalized learning experience related to collaboration that would likely include some of those self-reports, and actually thinking about having those self-reports alongside the audio data or alongside the transcript data from that given collaborative session.
Thanks.
See a hand up. Go ahead.
Yeah, thank you so much for your talk. I think the work you do is really amazing. I think maybe my question is, I have two questions. One of the questions might be related to Sean's question, which is about like how you deal with the kind of discordance or like discrepancy like between different measures in multimodal like data analysis. Yeah, like for instance, like I don't think you kind of like go deep into this issue. Like for instance, like when we analyze student behavior, like from verbal, nonverbal, the gesture, gaze, and their physical engagements. In the case of emotion, for instance, you have facial movement, you know, speech, and the verbal content. But then, like in the data analysis, you want to decide on a measure, or, you know, either integrate them or choose one, like to kind of analyze the data. But in this case of like emotion, for instance, measure, oftentimes there's poor concordance amongst those measures. I wonder like how you deal with that. Sorry, I kind of went into
no. That's yeah. So
I have another question.
Okay, I'll answer the first one. I'll answer the first one first, and that is that one of the commitments that we talk about is that when analyzing multimodal data in particular, I think it's important to engage the participants in that inference process. That there needs to be some feedback from the participants on like, hey, this is what I'm seeing from the data. Walk me through it. Let me please like help me understand like what you were feeling within that moment. Now, it's not to say that that approach is going to be perfect, because people don't always understand what they're experiencing. People always don't understand even like what their subconscious might be expressing. I get into this some because some of the studies I have, I'll use skin conductance or electrodermal activity, or using something like EEG. And the reality is that people don't always know quite what they're feeling. But in my view, I think part of our responsibility in using some of this multimodal data is to also take some of it back to the participants and kind of say, look, here's what we're seeing from this data. Like, can you provide some qualitative description or can you provide some insights to help us as we think about and interpret this data?
Mm-hmm. So like mixed methods kind of approach to, yeah, no, thank you so much. The other question I have is about like bias reduction. Like I really like this vision you had. I think the class you teach about inclusive making. I wonder like how having access to the multimodal kind of data of students, like moment by moment learning process, can potentially address this labeling issue, like labeling students with using like standardized test. And like how do you assess students' performance and growth experience using the new paradigm? Like,
so I maybe have time for this story. I'll see it at 1:55. So this kind of came about in a middle or high school class that I was leading at Stanford. So we had students coming to our Maker Lab for 2 months out of the year. There's one student in that class that when I watched him, I thought he was just always goofing off. Like he was always telling jokes. He was always seemed like he was a troublemaker. When I actually went back and watched the video of that class, I started to see that in one day in particular, I see someone come from clear the other side of the room to come ask him a question. And then he helps that person with that question. I see someone else come from a different corner of the room and come and ask him that question. And from what I saw in the moment, when I was in the class, I thought he was a class clown. And he did do some things that sort of would suggest that. But at the same time, I was missing out on the fact that his peers had started to recognize him as an expert in a certain area. And so I think the multimodal data, in that case, if I had like indoor location tracking set up, I probably could have seen some of those things emerge. I could have probably seen some of those activities start to show up. Now, having said that, I do have some concerns about just putting a bunch of these technologies in all kinds of learning spaces for the issues of privacy, for the issues of ethics that I mentioned earlier on. And so generally, I actually think about, what is the minimum amount of technology that we can provide while still providing tangible benefit, or while still helping us to interrogate the kind of questions we want to get at. And so many times what we'll do is we'll actually use the full suite of technologies in more of a laboratory context, so we can start to understand a given phenomena or understand a given practice, and then take the insights from that and apply it to the learning space with fewer of those technologies.
Thank you so much.
Looks like I see a hand.
Hey there. Yeah, thank you so much for this talk. This work is really vital and exciting to me. I'm curious to hear more about your research decisions in the design sessions that you run. And in particular, you said once students have access to tools to create their designs, they begin to see their agency. I'm currently running a participatory design and development project with 6th grade girls and non-binary youth as well. I'm trying to think, how much scaffolding or support do you give in bringing student designs to life? The more you give, the more excited they are to see, like, wow, we do these amazing things, but maybe a little less student agency than in that whole process. It feels a little less participatory. So yeah, thank you.
Yeah, I mean, that's really, it's hard to do. And I feel like it varies by student, in that for some students, they get such as this big idea, and then they get overwhelmed with that big idea. And I mean, adults, we do this too, but some of it has to do with trying to help kind of manage that scope, or even help be able to piece things down into like a smaller set of things that they can start to accomplish. So what are the kind of things that we end up doing? One is we do a lot of things with we'll actually bring prototypes that we've created, and sometimes we bring those prototypes that we've created so that students can start to see what some of those possibilities are. Other times, I feel like it is much more kind of student led, and sometimes it takes us down a bad path. Sometimes not, but I think we end up providing a mix of, here is very open-ended versus here is like fully scripted, of here's how you would actually create this thing, to here is the actual thing, like test it, use it, play with it. But there's not the expectation that they will actually have to go through and create all of those things. So I don't know that there's like a magic, I don't know that there's a single solution or a single sort of answer for it. I think a lot of it is to design for a lot of possibilities, design for the student who does just want to sit down and do it by themselves, and they will hammer it out for hours. Have a design available for the student who wants to get that scaffolding, and like it would be excited to just follow those instructions and get that thing working. And then design for the student who, a roadblock comes up, they're going to kind of throw up their hands and give it up. Because I think there's important pieces along all of those paths. And when we think about the timelines, we oftentimes think about like something being successful if the student finishes it within like a week or within 2 weeks. But we don't really know the full extent of the impact of some of these experiences, because it could be 3 years from now, it could be 2 months from now, where a student finally starts to make those connections. So to also, I think, temper our expectations for what success looks like within that space. Okay, I see.
Hi, thank you for the really interesting talk. So I'm curious to go back to the point you made right at the beginning about giving users control of data. You mentioned it comes with methodological challenges. So I was wondering if you could elaborate a little bit on what those challenges are and how you deal with them, and maybe how you were thinking about that in the context of Blink especially.
Yes, the methodological challenges. You know, we oftentimes in research, when we just go and collect data, the assumption is that we're getting a representative sample of student engagement, a representative sample of that interaction. And when we instead are getting choice snippets of interactions, choice snippets, the parts that people want us to hear, that starts to mess with some of the ways that we oftentimes talk about the findings. And so in one sense, it might push against concerns around the generalizability of these things. And, you know, I think for me, it doesn't create as much of a problem, because in many instances, what I'm looking for is just instances of students demonstrating some competency or demonstrating some interest or demonstrating something. But from the much more, I mean, they would probably say much more rigorous, more of like randomized controlled trial kind of level. They want to see all of the students' data all for the entire time to actually be able to run that comparison. And so I think because of that, we have to think about what are the kinds of methodologies or what are the kind of analyses that we would use that would align with this idea of students to be able to determine when the data is collected about them and when it's not. And at the same time, that introduces a challenge of being able to like resolutely provide appropriate support for the learners. So if it is just those choice moments that they're recording, we might be missing out on either important, meaningful contributions that they're making, or some of the challenges that might start to arise within that space. So those are some of the tensions that I feel like we start to think about. And one of the other ones that I'll quickly mention is that within the Blink platform, we do not record audio. There's no, like, we can record the audio, we can store the audio on our servers, but we don't. We run it through a speech recognition, and then we just save the transcript. That introduces a problem too, because one, we do that because we want to maintain people's privacy, but there's also this challenge of you now lose the context. You do not have a record to go back to say, okay, this is really what the person said. Instead, you're now relying on what was the output of the speech recognition system, when that actually might do harm in terms of how that student is being represented, or either how that group is being represented. So that ends up being one of these other tensions too, around sort of like adopting some of these commitments, adopting some of these practices, and how those things can still subsequently sort of introduce some challenges.
Thank you so much, Marcelo, for the wonderful talk. Let's all give Marcelo a virtual round of applause.
Thank you guys. Thank you.